Okay. Hello everyone. So let's learn the reduction of order method. So reduction of order method, we have a second order linear homogeneous differential equation here in the standard form. Now this method is based on the fact that we want to find the fundamental set of solution, that means y1 and y2, but we already know y1. And we use this fascinating fact that y1 and y2 are linearly independent. So actually y2 is u times y1, an unknown function u times y1. Now you will be given y1. That's the biggest thing. You already know y1, so you only need to find that y2. So what we are shooting for here is to find u somehow. So if we know u, if we know y1, we can multiply and then we can get the second solution. Alright, so to make our life easy, let's get rid of the subscript and say just generally y. Y is u times y1. Okay, good. So what we are going to do is we are going to do a substitution. Okay, y is u times y1. Now if you want to substitute this term into the differential equation, we have to find y prime, we have to find y double prime. So let's find y prime. So y prime, if you want to take the derivative of y, here this is a multiplication of two functions. So what is the technique that you take derivatives? Product rule, right? So what is product rule? Let's differentiate u prime, and then let's keep y1 unchanged. Now you keep u unchanged, differentiate y1, you get y1 prime. So let's find y double prime. Oops, not u prime. Y double prime. So y double prime is, now you differentiate this term. Well, we get u double prime y1, u prime y1 prime, u prime y1 prime, u y1 double prime. I have to be very careful. Well, I can see two similar terms. Well, I can write this as 2u. I can add those two terms and 2u prime and then rest of these terms. Okay. All right. Now let's substitute these terms into our differential equation carefully. So u double prime y1 plus 2u prime y1 prime u y1 double prime plus p times this term. So let's distribute the p among these two. Okay, pu prime y1 pu y1 prime plus q times, well, y ECC u y1 is equal to 0. Good. Now what we are going to do is we're going to do some algebraic tricks. First thing, I'm going to regroup them. Let's find the u double prime terms. So u double prime term is this. So u double prime y1. Let's find the u prime terms next. U prime terms are, well, these two. So I can, oh no, not these two. This term and this term, right? Pu prime y1 plus 2u prime u1 prime. Okay, now let's find the u terms. We found u prime, u double primes, u primes, now u terms. This term u y1 double prime, pu y1 prime plus q y1 is equal to 0. Okay, right. Now this gives us an interesting thing. Let's look at the u terms. Here we can factor out a u. Right, so if I factor out u, this will be y1 double prime plus py1 prime plus qy1. All right, so what is this term inside the bracket? This is almost the differential equation, right? Y prime plus py, y double prime plus py prime plus qy. Isn't that the differential equation? Substituted y1. Right, so you substitute differential equation, you substitute y1 to the differential equation, and this is what you should get. And y1 is a solution. So because of that, what is left hand side should be equal to 0, right? Okay, so this term supposedly 0. So all the u terms vanishes out. They are 0. So what's left is u double prime y1 plus, let's factor out a u prime here, u prime py1 plus 2y1 prime is equal to 0. Okay, we have a much simpler term now. All right. Now what we got right now here is a differential equation in terms of u. It's a second order differential equation. Now this is where the name reduction of order comes into play. Reduction of order means you reduce the order. So we have a second order differential equation. Now what we are going to do is to rewrite this differential equation as a first order differential equation. So then convert the second order differential equation into the first order differential equation. How can we do that? Well, we do another substitution or a change of variables. I'm gonna say W is U prime. I change the main variable from U to W. Okay, we can do that because we no longer have U terms. Okay, so if W is U prime, this term is W, right? W P Y1 plus 2Y1 prime. Now what is U double prime? If U prime is W, U double prime is W prime, right? W prime Y1. So see, now you all of a sudden you get a first order differential equation. This is second, this is first. Okay, so we have a first order differential equation now. Alright, so in the note I have solved this first order differential equation in the integrating factor method, but here I'm going to use the separation of variable method, so you can see the both ways. I highly recommend you to read the notes as well. Okay, all right, so we have W prime Y1. Let's take this term to the right hand side, negative W Py1 2Y1 prime. Well, W prime is actually dW over dx Y1, negative W Py1 plus 2Y1 prime. Let's take the W terms to the left, dx and y1 to the right by using separation of variables. So dw over w minus py1 2y1 prime dx over y1, right? By taking this y1 to the right, you take it by division. Okay, so let's divide the right hand side each term by y1. So we get negative p, y1 over y1 is 1, minus 2y1 prime over y1 dx. Well, now let's do an integration. So if you integrate the left hand side, you get natural log w, right? Okay. If you integrate the right hand side, well, we can integrate these two terms separately, right? We can integrate negative p, so negative p dx. Actually, we don't know what is p, so we cannot give a definite answer here, right? But let's have it like that. Now you have to integrate 2 times y1 prime over y1 dx. Now this is where one of the problems that we did in the previous quiz helps us. y1 prime means dy over dx, right? This y1 prime times dx with dx here. Now what is this equal to by the definition of differential? Oh, this is y1. My bad. So y1 prime is dy1 over dx, and with the dx, this term is actually this term here, right? So by the definition of differential, remember this is dy1. So what we get is negative p dx minus 2. This term is actually dy1. All right. Okay. So now we can integrate this term and write negative 2. If you integrate 1 over y1, you get natural log y1, right? We integrate y1 with respect to y1. Okay, plus c. C is an arbitrary constant. Let's call it c sub 1. Okay, so now we need to find the explicit solution. Well, before that, let's do some let's do some apply some logarithmic rules. This can be written as minus natural log y1 square, right? Let's keep minus here, c1. Okay, all right, this is natural log w. Let's take the e of the other side, w e to the integral of p dx minus natural log y1 square plus c1. Okay, so we can break up all these terms, w e to the integral of p e to the negative natural log y1 square e to the c1. Okay, e to the c1 is just arbitrary constant, so let's call it c. Okay, e to the negative integral p dx. Now this term I can rewrite as, we have seen this a lot, as 1 over e to the natural log y1 square, right? I can make this negative positive by taking this term to the denominator. Now e to the natural log y1 square is what? Y1 square. So this term is actually 1 over y1 square. We are almost done, okay? So this is actually divided by y1 square. So this is the answer. We are not done yet. So let's rewrite it. W is constant times e to the negative integral of p over y1 square. Okay. Alright, we found W. Now, what we need to do is, we know W is U prime. So actually W is U prime. Our goal is to find U, right? You know the derivative of U. How can you find U? Integrate, right? If you want U prime, if you want U out of U prime, you have to integrate U prime. So we will integrate this term once more with respect to X. Looks ugly, right? Wait a minute, okay? So C times e to the negative p integral of dx y1 square. We are going to integrate this whole thing with respect to X and we will produce another constant. Okay, let's deal with the constants first. This looks a little bit long and horrible and horrifying, but it is not, okay? When you solve the problems, you will see it's not horrifying as you think. For our simplicity, let's choose our C2 to be 0 and C to be 1. So I'm trying to make your life easy. We can choose these constants by ourselves, okay? So let's get rid of these constants. So we get U is equal to integral of e to the negative integral of p over y1 square. We integrate this with respect to x. C2 is 0, C1 is 1. So this is the solution for U. Now we know U. So what is y2? This U times y1, because we know y1. So actually the second solution is y2x. Second fundamental linearly independent solution is y1 times the integral of e to the negative px over y1 square dx. So this is the answer. Alright, let's pause here. Here's the thing. It's look like a big integral, and we are going to see lots of examples in upcoming videos, okay? Before I finish the video, let me say you a couple of things. Here we derived a formula to find y2. So given an example problem or exam question or homework problem, you can take two approaches. First approach is directly use this formula. Here we have a formula. It looks horrible, but it is not. It is very easy to implement. It's just you need to do integration twice and you have to do some algebraical simplification. Here you can see, here you have to do integration, here you have to do integration. If you want to use the formula, you have to have your differential equation in standard form and you have to identify p correctly, because see, you are using p in fact. Okay, so you have to identify p, then use p, then you can use this formula to find the second solution. That's the first way. The other way is to do this process from the beginning. Actually, it's the easiest, it's one of the easiest ways too. So you can avoid this type of two integrals. Okay, so there are two ways to solve a problem using reduction of order method. But now you cannot decide it by yourself. Definitely you have to check with your instructor whether you are allowed to use the formula or not. Okay, so it's totally up to instructor. Instructor might say, well, you can use the formula. If he says you can use the formula, you have to ask whether the formula is given in the exam or not. Otherwise, you have to memorize the formula. Or you have to ask from your instructor, should you have to go through the process instead of using formula to solve the problem using reduction of order method. Okay, so check that with your instructor, but I will show you plenty of examples doing in both ways, using formula and using the process. The what I prefer is the using the process. Okay. Alright, then see you in next video and we will get these things simplified in next few videos. Okay. Alright. Thank you.